Good morning, class.
Good morning, madam.
So, how are you all today?
I am fine. How are you, madam?
I'm good. So, today we'll be discussing about differentiation. In this lesson, we will be talking about definition of derivative function. The learning outcomes for this lesson is to state the formula for differentiation by definition, apply the formula for differentiation by definition to differentiate an expression. The learning objectives of this lesson is that I will explain differentiation by definition, discuss examples of differentiating an expression through the definition of differentiation, and I will also explain differentiation through the first principle. So class, do you remember limits?
Yes.
Do you know how to find limits?
No.
For this lesson, it is important to know the fundamentals of limits. So let's begin with the lecture. The process of finding derivatives is called differentiation. Differentiation is considered as a vital element in calculus because it represents change in function to respect of one of the variables. Derivative of x with respect to y can be denoted as df divided by dx. Note, it is important to know that d of f divided by d of x is not d of f divided by d of x, but instead it represents the derivative of x with respect to y. So this is our definition graph for the derivative function. Formula for finding the radius of the line passing through the 2 points. So as we all know how to find gradient, the formula of the gradient is change of y divided by change of x. Obviously we know change of y is simply means y2 minus y1. And change of x can be found using x2 minus x1. After substituting the y and x values from the definition graph, the final formula looks like this. So you must be wondering that how come this small formula suddenly became so substituted or big, right? So for this, we took the x and y values from that definition graph. So our formula for finding the gradient is gradient for finding the formula is change in y divided by change in x. As you all know, change of y equals to y2 minus y1, and change of x is x2 minus x1. So we got our y2, y1 and x2, x1 values from that definition graph. So our y1 is f of x and our y2 is f into x plus h. While our x values, our x1 is x and our x2 is x plus h. It's always better to note down y2, y1, x2 and x1 values to avoid confusion. Our y2 is after noting down the values for y2, y1, x2 and x1, we will substitute the values into the formula. So after substituting the values, this is what the formula looks like. But we are still not done here, because I can see that our x can be cancelled and can be written in a more simplified form. So our x minus x will cancel off. So our final formula would be so this is how we got our formula from the x1, x2, y1 and y2 values from the definition graph and using the gradient formula. Now as height approaches 0, the chord becomes tangent at the point x1, y1. So this is our tangent point, which goes from x1, y1 to x2, y2. Thus the gradient of the tangent at x1, y1 is equal to limit as height approaches 0, and the formula we derived from the definition graph. Note that this is known as differentiation from the first principle. Whatever we did was differentiation from the first principles. So the steps to find derivative using the first principle of differentiation. Step 1 is to find f into x plus h by substituting x plus h in place of x in every fx. Step 2, we need to compute the formula we derived and simplify. Step 3, find the limit by substituting 0 in place of h. So let's look at this example. Differentiate f of x is equal to 3 minus 2 by using the first principles. So this is the expression given to us. We have to use the first principles. Step 1. We need to find f into x plus h by substituting x plus h in place of every x in f of x. So in this expression, we can see that there is only one x given. So basically, we will substitute x plus h in place of this x. So 3x will become 3 into x plus h minus 2. After simplifying, expanding, we will get 3x plus 3h minus 2. So our f of x plus h is 3x plus 3h minus 2. So this is basically our step 1. And our step 2, we will compute the function and simplify. And which function we will compute? Those expressions using this formula. Step 2. So basically in step 2, we need to compute the formula we found from our definition function. So we will compute limit as h approaches 0 and the formula f of x plus h minus f of x divided by h. After computing the formula, we need to simplify this. So f of x plus h is 3x plus 3h minus 2 and our f of x is 3x minus 2. As limit h approaches 0, 3x plus 3h minus 2 minus f of x is 3x minus 2 upon h. We cannot just start cancelling off and simplifying the equation. First, we need to expand this. Limit as h approaches 0, 3x plus 3h minus 2. This will become negative 3x and this will become positive 2 upon h. Can you see any common factors over here? Well, I can see 3x and negative 3x, negative 2 and positive 2. So 3 and negative 3x minus 2, negative 2 and positive 2 will cancel out. So we will be left with limit as h approaches 0, 3h divided by h. We still not done here. As you can see, it's 3h divided by h. So this h and this h will cancel off. So we are left with limit as h approaches 0, 3. For this question, there is no h, so we won't substitute 0 in place of h. So basically there is no step 3 for this one. Since there is no h, so we will skip step 3. So basically our limit for this question is 3. For example 2, I will let you guys to try by yourselves. I'll give you 5 minutes to try out the example 2 and after that I will discuss the solution. Step 1, we need to find f of x plus h. So we will find our f of x plus h by substituting x plus h into every x expression in the function. So f of x is 5x squared plus 2x. So 5x into x plus h squared plus 2 into x plus h. We have to expand this. So x plus, and for this one, before expanding this one, we have to find x plus h squared first. So x plus h squared will be same as x plus h multiplied to x plus h. So x times x will give us x squared, x times h will give us x plus h times x will give us xh, and h times h will give us h squared. This can be also written as x squared, since we know xh and xh are common factors, which will give us 2xh plus h squared. So our x plus h squared is now x squared plus 2xh plus h squared. And when we will expand this bracket, we will get 2x plus 2h, and expanding this, we will get 5x squared plus 10xh plus 5h squared plus 2x plus 2h. So basically this is our f of x plus h. Step 2, we will compute our formula and simplify. So limit as h approaches 0. Do you remember the formula we derived from the definition of derivative function? We are going to use the same formula, which is f of x plus h minus f of x divided by h. So as we know, our f of x plus h is this long expanded formula, and then is our f of x. This is our f of x plus h we found over here, and our f of x is 5x squared plus 2x. Before going to the next step, we have to first expand this bracket in order to solve and find the common terms. So we will get f of x h plus 5h squared plus 2x plus 2h. So we will get negative 5h squared into minus 2x divided by h divided by h. So we have to identify the common factors. 5x squared and negative 5x squared can be cancelled. 2x and negative 2x can be cancelled. So after cancelling this, we will be left with important to write limit as h approaches 0. So limit as h approaches 0, 10xh plus 5h squared plus 2h upon h. So after cancelling out the common factors, we will be left with this. This needs further simplification, so this expression is divided by h. So 10x divided by h, we will get 10x. 5h squared divided by h, we will get 5h. And 2x divided by h, 2h divided by h, we will get 2. Step 3. We need to substitute 0 in place of h. So limit as h approaches 0, we will get 10x plus 5h plus 2. Students, can you spot any h over here? Yes, 5h. So in place of h, we will substitute 0. So 10x plus 5 into 0 plus 2. So this basically will become 0. So 10x plus 2. So this is our limit for question 2. If you have any questions, you can feel free to ask me. So guys, this is the end of this lesson. I have printed some practice problems for you.